Hi friends, welcome to my YouTube channel. This is lecture number 8 and today we are going to study switching characteristics of thyristor. Switching characteristic of thyristor is also known as dynamic or transient characteristic. It is basically turn on and turn off characteristic of SCR. Turn on time of SCR is equals to delay time TD, rise time TR and spread time TP. While the turn-off time of SCR is equals to reverse recovery time TRR and gate recovery time TGR. So we can say that whole characteristic is divided into 5 important time slots, that is TD, TR, TP, TRR and TGR. First we start with delay time TD. See this characteristic. Initially the thyristor is in forward blocking mode. During forward blocking mode, a small amount of current, that is forward leakage current, flows. This current is very small and voltage across thyristor during forward blocking mode is VA. Now gate current is applied at T is equals to 0. When gate current is applied, gate current starts increasing. See, this is time period TD. Now what happens during this TD? During delay time TD, anode current rises from forward leakage current to 0.1 IA, where IA is the steady state anode current, or we can say that anode current flowing during turn on. Anode voltage falls from VA to 0.9 VA during this time period TD. Now this happens on the characteristic. Now we will see what happens inside the thyristor. See the gate cathode junction. This is gate and this is cathode. As gate current begins to flow from gate to cathode, gate current has non-uniform distribution of current density. This non-uniform distribution of current density is over the cathode surface area. How this is non-uniform? We can easily see here that gate current density is more near the gate junction and it is less as the distance from gate increases. We see here that these lines are sparsely located as the distance from gate increases, while these lines are densely located as the distance from gate decreases. So gate current density is much higher near gate and it decreases as distance from gate increases. Now anode current flows in a narrow region where this gate current density is high. So here we can see that gate current density is high near this gate junction. That's why this anode current will flow over this small area. This circle denotes the conducting area of cathode, and here this dot denotes that anode current flows over a very small area. So now anode current flows in a narrow region near the gate where gate current density is highest. This narrow region is shown by this green enclosed area. Okay, delay time can be decreased by applying high gate current and more forward voltage. Delay time is fraction of microsecond. Now we will see rise time TR. During rise time TR, this time is rise time TR. During this rise time TR, anode current rises from 0.1 IA to 0.9 IA. and anode voltage falls from 0.9 VA to 0.1 VA. Here in corrector state, during rise time, both anode current and anode voltage are high. That's why turn-on losses are high during this rise time. Now what happens inside the thyristor? From the beginning of rise time, anode current starts spreading, but it is not able to spread over entire cross section of cathode. So during rise time also, anode current conducts over a very small area. Here this circle denotes the conducting area of cathode, while this small dot inside it denotes the conducting area of anode current. Here we can see that anode current conducts over a small area. So there are two important points in this period. First is, during this period, turn-on losses are highest, and second important point is, anode current conducts over a small area. From these 2 points we can conclude one another important point, that is, these losses are concentrated over a small area where anode current flows. This concentration of losses over a small area results in local hotspots. Rise time is inversely proportional to the gate current. It means as gate current increases, then rise time decreases. Second point is, for RL circuit, rate of rise of anode current is slow due to inductor, because inductor opposes the change in current, so rise time is more, while for RC circuit it is less. We can conclude from this that turn on time depends on the L by R ratio of load. So here is the question that has been asked in year 2014. If the turn on time of SCR is 7 microseconds, an ideal gate trigger pulse should have a short rise time and a pulse width of 8 microseconds, a short rise time and pulse width of 4 microseconds, high rise time and pulse width of 4 microseconds, high rise time and pulse width of 8 microseconds. To answer this, you must know that rise time is much higher than this delay time and this spread time, because this delay time are in fraction of microsecond. That's why this rise time is considerable, or we can say that turn on time is nearly equals to rise time, or turn on time is slightly greater than rise time. That's why my answer is high rise time and pulse width of 8 microsecond. Now next slide, spread time Tp. This time period denotes the spread time Tp. During spread time Tp, anode current rises from 0.9 IA to IA, while anode voltage falls from 0.1 VA to forward voltage drop, that is called on-state voltage drop Vt, that is nearly equals to 1 volt. Conduction in this period is spread over entire cross section of cathode. After spread time Tp, steady state operation start. Steady state operation means SCR goes into forward conduction mode. During forward conduction mode, full anode current flows and there is very small voltage drop across SCR, that is called on-state voltage drop Vt, and that is equals to 1 volt. Manufacturers generally indicate rise time instead of turn on time. Why they do so? As I already told you, this is because delay time and spread time are very small, that is fraction of microsecond. That's why rise time is nearly equals to turn on time. Now total turn on time can be reduced by injecting more charges in less time. So turn on time can be reduced by using higher values of gate current. This concept has been asked in ES 2014. Now we will discuss the turn off process. As I already told you that turn off time is sum of reverse recovery time TRR and gate recovery time TGR. First we will see TRR. TRR is the time period between instant T3 and T1. This is T3 and this is T1. When reverse vice is applied, this anode current starts decreasing. At T1, anode current becomes 0. After that, anode current starts decreasing with di by dt slope. This decrease in current after T1 is due to presence of stored charges in alternate P and N layers. Between T1 and T3, this is T1 and this is T3, reverse recovery current flows. This negative direction current is called reverse recovery current. This reverse recovery current flows due to sweeping out of holes from P layer and electrons from N layer. At time T2, this is T2, around 60% stored charges are removed from outer two layers. After T2, carrier density across junction J1 and J2 begins to decrease, which leads to decrease in reverse recovery current. Now this decreasing reverse recovery current causes a reverse voltage. This is reverse voltage, which is very dangerous. It may destroy the SCR. Now at instant T3, the reverse recovery current falls to nearly zero. Here we can see that at instant T3, this reverse recovery current is nearly zero, and junction J1 and J3 recovers. Okay, after that SCR is able to block the reverse voltage. Here there is a question that has been asked in ES 2000. It was on the concept that between instant T1 and T3, reverse recovery current flows, which removes the excess carriers from junction J1 and J3. So this is important. Now move to next slide, that is gate recovery time TGR. This TGR is between instant T3 and instant T4, and this is instant T3 and this is instant T4. So after T3, this is my T3, we can see here that reverse current is not equals to 0. Still it has some trapped charges. That's why this reverse recovery current is flowing. These trapped charges can only be removed by recombination. This recombination is possible if a reverse voltage is maintained across SCR. At T4, junction J2 recovers and forward voltage can be reapplied. So the summary of total turn-off time is that during TRR, junction J1 and J3 recovers, while in time TGR, junction J2 recovers. During TRR from T2 to T3, what's happened? During T2 to T3, this reverse recovery current decreases, and due to decrease in this reverse recovery current, a reverse voltage appears across SCR, and it is dangerous as it may destroy the SCR. Now next important point is turn-off time depends on junction capacitance. Turn-off time increases as the anode current increases, or di by dt at the time of commutation increases, or the junction capacitance increases, or the reverse voltage decreases. Turn-off time decreases as lifetime of carriers decreases by doping with gold or applying a negative pulse to gate. Now take some important points. First is turn-off time provided for practical circuit or time for which SCR is reverse bias by commutation circuit is called circuit turn-off time, and it is denoted by Tc. The time Tc must be greater than Tq for reliable turn-off. Converter grade SCR. These converter grade SCRs have slow turn-off time, that is around 50 to 100 microseconds. They are used in phase control rectifiers, AC voltage controllers, cycloconverters, etc. This classification is very important because a question has been asked in ES 2004 from this point. Inverter grade SCR. Inverter grade SCRs have fast turn-off time, that is around 3 to 50 microseconds. Application of inverter grade SCRs is in inverters, choppers and force commutated converters. And this is very important point because question has been asked in ES 2014 and GATE 2011 from this point. But when you will study rectified circuit, then you will get familiar with this concept. So this is very easy concept. There is no need to memorize this. You will come to know more about this concept when we will study rectifier. So that's all about this video. I hope you like this video. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.